Good morning, students. It's Ray here doing another video for you math enrichment people on slope and rate of change, okay? So this is a preview of what we're gonna be doing next week when we finish the map assessments, okay? So we're basically gonna look at slope and rate of change, which is basically the same thing, or the ROC, through graphing mostly, okay? So I'm gonna really try to focus on that so you guys get an understanding. We're also in class, we're gonna look at it in terms of verbal statement as well, and also a table. But I think those are pretty easy to do. So we're going to basically focus on these 2 points because I think this is the one that's the most toughest for most kids. Okay, so let's get started. All right. So first thing is going to look at this graph here, and basically we have a graph on the left. We have distance and we have time. So the time we know is going to be the x. The distance is going to be the y. Okay, we know that. All right. So we have 2 points here, and then we make a line to be a graph. Okay, that's not a good guy. Okay, erase that. Make a better line. All right. Okay, that's a better line. Now, what do we have here? So basically, we have to find the slope or the rate of change of this line itself. Okay, so what do we know? All right, we know that this coordinate point is the coordinate point of this would be 4. Let's write this down. Three. Okay, write this down here. Now the other one on this top right here, the coordinate point for this one would be 9, 7. Okay, so those are 2 important coordinate points. All right. So what we're saying to you here is basically, okay, how do we find the rate of change between these 2 coordinate points so we can actually find the slope? All right. So first thing we have to look at is, okay, so what is the difference between going up and getting to this point? Right. So if we could make a line here, make a line to make it actually end up making a triangle. Okay, if it's doing it actually right for me here. All right. Okay, so here's the line. All right, so this would be the rise. Okay, how far does it rise to get to this point? So we say we start at 3 here. Right here's 3, and it ends in 7. So the difference between 3 and 7 is 4. Okay, and now if we look to the side, okay, how far does it go to the right to get to this point? Okay, so we go from 4 here, 4, and then we go to 9. So that difference would be 5. Okay, so then all we have to do at that point is put the labels onto it. Okay, so we can actually figure out what the rate of change is. Okay, so every time that we go from different coordinate points, we should go 5 minutes. Okay, and then we also go 4 feet. So that would be our rate of change. Okay, so 4 feet per every 5 minutes. Okay, so if you think about it, all right, if we continue to make this line going down, that every time we should have the same kind of rate of change every time. We should have 4 feet every 5 minutes, 4 feet every 5 minutes. So that would be the rate of change for the whole thing. So I'm just going to do 4/5. Okay, and that's how you would determine it. Okay, but I mean that looks pretty easy if using it from a graph, but there's an actual formula for this. So let me give you that so we can have that down. So let me write slope. Okay, and let me give you the formula. Okay, so the actual formula is change, or change is usually done with a little triangle here. Change in y over change in x. Okay, we're also going to talk about it as terms of equals rise over run. All right. Okay. All right. So the change in y over the change in x. Okay. And the easiest way people have already probably seen this way is basically y2, the coordinate point y2 minus y1 over x2, coordinate point x2 over x1 minus x1. Okay. So it's usually these are the normal ways you usually see it, but the one we're going to focus on today is this one right here. Okay, and that's going to help us basically be able to solve these type of problems. Okay, but all these things mean the same thing. This also means rate of change. I'm going to get ROC as well. Okay, so those are important information for today. Being able to use these. All right. So let's try and practice here. All right, so we have two coordinate points. We have 12, whoa, sorry guys, okay. We have two coordinate points here. We have 12 and 16. That would be my X and Y. Okay, and then we have negative 20 and 4. So this would be my X2. This would be my Y2. Okay, so I'm going to use this equation on the top here to actually go ahead and find the slope of the whole thing. So slope. Okay, so let's put this in order here. So Y2 goes first. So that goes on top, minus whatever Y1 was, 16. Okay, and then X2 is negative 20, minus, what is that? Let's see, and that's 12. Okay, so again, this is a very important thing is remember positive and negative integers, making sure that you know exactly where your negatives and positives, and make sure you flip that over when you do the work, okay? Because it's going to really change your answer if you don't. All right, so that's how we would do it. Rise or run. So all the Y2 and Y1 would go together in X2 and X1. But people always have the question, does it always have to be Y2? Okay, does it always have to be Y2 goes first? Like, no, you can put Y1 goes first, but the bottom has to be the same. So if you put Y1 as 16 minus 4, okay, that's fine, but your X2 would have to be 12 minus 20. Okay, do you see what I'm saying? So it always has to be in order, the same way order the coordinate point is. Okay, so let's do the math here. So we have 4 minus 16 is negative 12. Okay, and that's over 20 minus 12, which is negative 32. Okay, and that's how it would work. So then I just reduce the fraction down. So how many times does 12 go into 32? I think it goes out. See, 4, yeah, 3/8. So it goes divided by 4, both top and bottom by 4, because that's the greatest common factor between both of them. And I can use negative 4 because then I can turn it to positive. All right, so that would become 3/8. And that is my rate of change after I can write it. Hold on a second. I can put it down. My rate of change is 8. Okay, and I'm done, 3/8. So that would be my rate of change in that situation. Okay, so that's how you would do it. Basically, put Y1, make sure you match them up, put them in slope in that form, change in Y over change in X, and solve it and reduce it, and that would be your rate of change. Okay, so let's try another one. All right, so let's see it again. So we have 21 and negative 10 is a coordinate point, and 7 and 24. So this would be my X. This would be my Y. This would be my X2. This would be my Y2. Okay, so let's do the work here and let's finish this off. Okay, so again, this would be 7 minus 21 over, okay, Y2 would be 24 minus 10. Okay, I always do Y2 and X2 over X2s first because it's just ways I remember. Okay, so 7 minus 21 is negative 14. Okay, that's 1. And then we have 24 minus 10. So minus, negative and a negative turns to positive. Okay, and so that value becomes 34. Okay. Now, if I do my math here, I'm going to divide both of them by 2. It should be divided by 2, right? Yeah, 17. Yeah. Divide them both by 2 because that's the greatest common factor between 14 and 34. Okay, and that's going to give me the value of 7, negative 7. Okay, and this one is going to give me 17. So we have negative 7 over 17, and that would be the value there. Okay, and that would be the slope or the rate of change. Negative 7 over 17. Now again, remember, there's some labels to each one, so that there's different rates to each one. So it's really going to make sense once we start doing some word problems and stuff like that. These things. Okay. So let's try a couple more. All right. So we have some graphs here. So let's use these graphs to actually work these kind of problems. All right. Let me make another layer too, so you guys can see my work. All right. So what we have to do now is we have to figure out which points are on the line to make, and then we can make a rate of change. So I'm going to take this point right here, and I'm going to take this point right on the y-intercept right here. That's the two easiest one I see. Okay, and that's going to give me my rate of change. Now I could do it one way. I don't have to actually do the calculations out. I can actually just look. Okay, so the rise, this will rise right up here, and then we just figure out the run. Okay. So all I have to do is count how many spaces goes up. So I go 1, 2, 3, 4, 5. Okay. And I know I go 1 over 1. So basically my slope in this situation would be 5, because that's the y, over 1, and that would be the slope of the rate of change. Okay. Now let me prove that mathematically. Okay. Okay. Let me prove that mathematically so we can actually see it. So all I have to do is count. So how many, count for the origin? 1, 2, 3. Okay, so this is 0, 3, because it's the y-intercept. Okay, and this is, let's see here, let's go over 1 to the right and up 2. So this would be over 1 to the right. Okay, yeah, it would be over 1 to the right, up 2. Yeah. Okay. All right. So let's do some math here to figure this out. Okay. Actually, this would be -3. Sorry about that. That would be -3. All right. Now it'd be +1. All right. So let's do this math and figure this out. So again, this would be my y. This would be my y2. This would be my x2. This would be my x1. So let me put my y2 here, minus -3. Okay, and I put that over, and that's 0. Is it 0, 1? No. Yeah, a 1 minus 0. Okay. Now, if you look at this, now we have a negative and negative that turns to positive. Okay, old school positive and negative integers. We talked about that before. Okay, so 5 over 1. And there you go. I have the same answer. So again, you can find it out either way. All you have to do is pick some points on the line and then just basically figure out, okay, what's the rise over run, or we can put it back in the equation and get the same answer. Okay. So again, it's foolproof the way you do it. So we have some points already put up on this one. Let's look at this one right here. We already have some points. We have a y-intercept here. Okay. I'm just going to count over. I'm just going to count over on this one. Okay. This is actually pretty easy to do that way. All right. So again, so if I count up, how many spaces? 1, 2, 2 spaces up. Okay, and 1, 2, 3, 4, 4 spaces this way. So again, that's how it would work. So basically, it'd be 2 over 4. That would be the slope, and then reduces to 1/2, and that would be it. Okay, but let's prove it to make sure we're correct. Okay, so it'd be again, this point right here is 0, 2. Okay, because that's the y-intercept. I like using the y-intercept because it's easy. And then this point right here would be 4 over. So this would be 1, 2, 3, 4. So this would be 4. How many up? 1, 2, 3, 4. So 4, 4. Okay. And if I do my math here, basically I got y2, which is 4 minus 2 over 4 minus 0. Okay, and it's where I get my 2/4. Okay. 2/4, and that equals to 1/2. And And that would be the answer to the question. Okay. So as you can see, we're able to get the slope and the slope rate of change by just using the graph by rise or run, but we also can get it by just solving the problem by using the rise of change in y over change in x. So that's all we're going to do today. In class, we're going to talk about a little bit more about verbal statements and trying to add that in and trying to, then we're going to have a big problem at the end that we're all going to do. Okay. All right. So thank you guys, and we'll talk soon. All right. Bye.